Hi future P's, welcome to the channel again. In this video, we are going to discuss gradient. Gradient falls under time value of money, which is a topic within engineering economics, and engineering economics is section number 4 of the FE electrical and computer exam specification. Without further ado, let's dive into the content. This is a very interesting question on gradient. And the student is asking an age-old question regarding gradient. And that has to do with the fact that why is the time period not n minus 1? And I've explained this in quite a bit of depth in the on-demand course as well as the live training. And I'm going to take this opportunity to go over it again because the student had asked me, followed up with me on this. Okay, so this is a practice problem coming from the on-demand course. And first of all, when we are dealing with gradient, students sometimes confuse gradient and annuity because present value is sort of one-time payment today. Future is one-time payment in the future. But annuity and gradient occur intermittently at a specific period. Okay, actually periodically. Intermittently is the wrong word. They occur periodically at a specific time after a specific period, right? The easiest way, if you're looking at a 10,000 view of things, to differentiate, distinguish between annuity and gradient is that annuity is a fixed amount and gradient is an increasing or a decreasing amount that increases or decreases by a constant value. Now, I must point out, as I mentioned in the live class as well, that there are so many different types of gradients. There are exponential gradients as well, okay? And they are declining, double declining. There's so many different variations, but for sake of simplicity, we are dealing with the standard linear type of a gradient, where it's a constant amount, it's increasing or decreasing by that amount. And we've actually looked at the declining gradient examples as well. Okay, so where the most important thing that we need to figure out right up front is identification that this problem is a gradient problem. Now, of course, when in the course, when I present this in a lecture titled under gradient, I think it's a no-brainer for anyone to figure out that, okay, this practice problem is going to test me on gradient. So you are then primed to think along those lines. Make sense? But assume that this is not given. Obviously, they're not going to explicitly tell you. They may or may not, but I mean, they're not required to sort of categorize the problem for you. That is part of your test, right? And if I read through this problem quickly, we have maintenance cost. And as explained in the on-demand and live training as well, it's typically like the maintenance cost, the wear and tear that, think of an old car, right? When you buy it new for the first 5 years and you don't have to take it to the mechanic. And that's why all of the car manufacturers are happy to guarantee the warranty, provide you the warranty for the first 5, 8 years or X number of kilometers, right? Because they know that it is not going to be encountering any major issues, right? But right after your warranty expires, that's when the car starts creating problems. And same thing can be said for life insurance. Typically, as you age, right, life insurance cost premiums, they also go up. Health insurance, same thing. Okay. So we have a small business owner, maintenance cost, M1 is equal to $1,000, M2 is equal to 1,500, 2,000, 2,500, 3,000, 3,500. Now, we can very easily solve these type of problems when we look at them as a gradient riding on top of annuity. Okay. So this is the cash flow. Strongly recommend you to actually put the numbers on a graph. It will help you make this conclusion much, much faster, get to this result much faster. Now, when I break this up, the foundation, right? If I slice it from here, Okay, if I take this portion out, the highlighted portion out, imagine that I'm able to do that, right? I extract it, right? So this 1K is going to become 0, right? I mean, there's nothing here. This is just 1K. And that's why you see a 0 over here. And that's really the crux of the question over here, right? So if I look at it as a sum of annuity and a rising gradient, for annuity, it's pretty simple because it's 1K each year going all the way up to 6. So n is equal to 6, and I receive multiple questions on this type of a scenario that when I start counting the number of arrows, which is first of all the wrong approach. In gradient, we don't count the number of arrows. If it's a pure gradient that basically we've extracted, right? You gotta realize that the cash flow of a gradient is a little bit odd. You don't have any cash flow in year 1 and year 0. Does it make sense? The payments are going to only start increasing after the first year or the first period. Okay. So if I were to count the number of cash flows, the arrows pointing upwards or downwards, I would come up with 1, 2, 3, 4, and 5. That's incorrect. Okay. There is a cash flow over here. It just happens to be a 0 cash flow, right? So the number of compounding periods, okay, that we have to take into consideration, the value of n is defined as compounding periods, right? And we use the same term in the context of annuity and gradient, right? Okay. Because if you look at the reference handbook, the very first page under engineering economics, they have nomenclature and definitions. I know it probably threw you guys off a little bit. There is no compounding, it's a fixed amount. So why is he using the word compounding period, right? If you go to engineering economics in the reference handbook, under nomenclature and definitions, you're going to see n defined as number of compounding periods or the expected life of an asset. That's what the definition of n is. Okay. So be comfortable with seeing a 0 cash flow in year 0, which is today, year 1 as well, when it comes to a pure gradient. And then the problem really requires you to convert all of this into a present value, which is pretty simple. And these interest rates and the compounding periods are given in the interest rate table that is provided in the reference handbook. So that should be fairly simple and straightforward. Okay. So yeah, gradient doesn't start until year 2. That's wrong. Even that statement is wrong. Gradient is starting from year 0. All of these cash flows, even in annuity, the cash flow is starting from year 0. It's just a $0, right? That is still a value. Okay. So please, the big takeaway is that as soon as you see a problem related to annuity or gradient, you need to be on high alert. You need to have your spidey senses going off, okay? Because this is much more difficult typically as compared to a present value and a future value problem, especially when it comes to gradient because of 2-0 cash flows, okay? And if you remember, in the live training, I specifically brought this to your attention that don't simply count, and this is really a screenshot from the live training. Don't simply count the number of arrows for n of gradient because a gradient cash flow is a 0 over here, right? A 0 here, a 0 here, 2 zeros, right? In year 0 and year 1, okay? So what are the key insights? Cash flow in year 0 of a pure gradient is 0, and that is true for year 1 as well. Gradient is characterized by a periodic payment that changes by a constant amount from one period to another period. So that is identification of gradient. Okay. And we have several practice problems in the on-demand course, in the quizzes, solved lecture problems, additional practice problem lectures, homework assignments, mini exam, computer simulated practice exam. Most of you are also using the study guide. So systematically work through gradient problems And just like how I recommended you guys for circuit analysis, if somebody is weak in Norton analysis or Thevenin theorem, then I suggested that you organize all of these practice problems from the course, from the live training, from the study guide, the quizzes, and everything, and systematically work through a variation and a variety of these problems that are on the same topic, and understand, compare, and contrast the subtle differences between each one of these problems, because I've gone out of my way to make sure that each problem is as unique as possible between all the different resources. Okay. So as an examiner, as a tester, between A, P, and F, okay, annuity, present value, future value, and G, gradient. Gradient is going to offer me the greatest amount of room to maneuver and make things challenging for you.